Hello everyone, this is Pauline Angel, URK20CS1015 from the Department of Computer Science and Engineering, Karunya. In this video, I'm going to explain you how to solve a fractional knapsack problem using greedy solution in design analysis and algorithm. So let's get started. First, let's see the algorithm for this particular problem. So using a greedy solution, we can use it for two kinds of problems. First, minimization problem or maximization problem. So, and this knapsack problem is nothing but it's like a container problem in which we'll be giving different kinds of items, their values and their weights. So we'll be calculating which having a maximum capacity to that, we'll be calculating how many kind of items or how much values, how many values we can take without exceeding the particular maximum capacity and also not losing the maximum profit. So for this kind of problems, we'll be calculating a value by weight ratio from the items which we are going to take from the user and then storing them in a descending order so that it will make the computation or sorting easy. So then later we'll be having a function called here in the algorithm we have given greedy fractional knapsack function in which it is having arguments for the weights which you are going to take from the user, values and also the maximum capacity. So for all these values we are going to assign a value called x, in which whenever we are going to consider a value, then we'll be incrementing this x value as we have taken it, considering that we have taken that particular value into the consideration. So for that, we'll be initializing the current weight as 0. So basically, the starting weight will say that the container has no values in it, no weight has been added, so that the initial weight is 0 now. And then profit also is 0 because we still haven't started taking or considering the inputs or weights. So after initializing all these values to 0, then we'll start taking the values into consideration. We'll be seeing what values and how many values or how much weight we can add into the container. So for every value from 1 to n in the particular number of values that the user has given, we'll be considering the current weight and adding that particular value weight. If the value weight is first value weight is 10, we'll be adding 0 plus 10, which should be less than the maximum capacity. If let's say the maximum capacity is 15. So if the weight 0 plus 10 is 10, so it is less than 15, then we'll be saying that x of I, which means this I is the value. X of I, the value 1, which is having the weight as 10. So we'll be taking into consideration, so that this x value will be saying that we have considered this particular value, and then representing it, we'll be saying it as 1. So after that, we'll be updating the value of the current weight, which means the weight which is initially 0 has been added as 10. 0 plus the current value weight is 10, let's say 10. So the weight will be updated as 10. And also the profit, if the value is having a particular profit, we have initialized it at 0. So we'll be taking that particular value profit and we'll be adding to the current profit. Or else, if this condition has been failed, if let's say the particular value is having more weight than the capacity that it has still remaining. If let's say only 2 kgs is left to get the maximum capacity filled, but we are having 3 items in it, then we'll be taking only 2 by 3 items or 2 by 3 items or values to be considered, which will be filling the remaining 2 kgs in the maximum capacity. So for that, we'll be dividing it, x of I will be dividing it so that only a fractional value of items will be taken into consideration to fill the maximum capacity. And then we'll be updating it to the weight again, and the profit will also be updated. and then it is going to come out of the loop, and again it will be going for the next item into consideration. So this is the algorithm, and now let's see the program, how to code it. Just like I have explained in the algorithm, I have taken the inputs from the user, like number of items and the values for the items, the weights, and their and the maximum capacity. And then I have given a function definition here called greedy method, which is taking these values, weight, and capacity. And then here I'm going to keep them in a descending order. So for this, I have sorted the particular values at which we have taken, and then I have initialized the maximum value as 0, and then the x values as 0 again. And now the actual computation starts here. So for every value of value in the index, we'll be checking its weight. If the weight is less than the capacity, then it will be initializing x of I as 1, and then the maximum value, it will be incremented, and also the capacity will start decreasing. Like if the maximum capacity is 40 or 15, let's say 15, if the maximum capacity is 15, whenever we add this particular value's weight, the capacity will start reducing, and finally if it is going to get filled, the capacity will be almost equal to the maximum capacity limit. So for that, we'll be reducing the capacity of for every increment that we are going to do here. Or else it is going to the else condition, which will be taking the fractional value of the particular item's weight, and then it will be incrementing the maximum value. So here, let's run this code and see. It is asking for number of items, let's say 4, and values of the items in order. Let's just give basic numbers 1, 2, 3, 4, and then positive weights of the items, let's say 12, 23, 65, and 12, and maximum weight, let's say 40. Now let's see what it has given us. It has given the maximum value of weights that can be carried as 6, and then the fractions in which the items have been taken, like the value from the item 1, it has taken not completely 0, but it has taken some kind of fractional value. If we have seen here, if you it is displaying some decimal number, which means it might have taken a fractional value from this particular item 1, and then from 2 it is displaying as 1. So definitely this 23, weight 23, in which item 2 is there, it has been considered, and from item 3 it is 65, weight 65. So since it is really large than the maximum weight, it might not have considered this particular item, so it is 0. And then for the fourth item, it has the weight of the fourth item is 12. So since it is less than 40, even after adding 23 and 12, it is less than, it's 35, so it's less than 40. So it might have considered this value weight 12, which is item 4 also, so it is displaying 1. So the remaining 5 kgs or 5 maximum weight, 5 capacity still remaining, might be taken from this item 1, which is, it is displaying some fractional value for that. So this is how we can solve knapsack problem using greedy solution. So hope you understood this program well. Thank you for watching. Have a great day.